In the previous video, we saw that when a price changes, it triggers a variety of potential consumer responses, driven by the change in the feasibility constraint. For example, the change in the wage, that is the price of labor services, from $15 to $25 per hour, gave you the opportunity to buy more consumption, but also more free time. So a change in the price allows you to consume more of everything, as if your income has increased. We call the effect due to the increase in income with the fancy name income effect. The income effect tells you what part of the change in your behavior is due to the change in your purchasing power only, not the price, only the income. But notice that when your wage has increased, your free time became more expensive. You're effectively losing more money each hour you don't work. So you will very likely demand more work and less free time as a result of this. The change in your behavior, which is only due to the change in the price of labor, is what we call substitution effect of a price change. We economists are curious people, aren't we? We see the consumer moving from point A to point D, right? This movement is observable in the consumer data, but we want to know why has the movement taken place? Was it because the consumer feels richer, or because their free time is more expensive? In other words, we want to isolate the income effect from the substitution effect. So let's see how we do it. So here's a consumer who moved from point A to point D as a result of a price change. This price triggered a change in her behavior in two ways. On the one hand, she felt richer and started buying more of everything, which we called an income effect. But on the other hand, she also felt that free time is more expensive now, which meant she would be substituting labor for free time, which we call the substitution effect. We want to isolate the impact of the change in income from the change in the price on her behavior. So how are we doing it? Let's do a mental exercise. What if our consumer faced the old prices, but is already at her new indifference curve? Again, old prices, new indifference curve. What will this give us? It will tell us that if prices didn't change, but only income has changed, the consumer will be choosing point C. Why is that? Notice that the prices at point A and point C are the same. This is because the slope of the two budget constraints is the same. Having identical slopes on the two budget lines means that the consumer is able to substitute free time for consumption at exactly the same rate. But if that's the case, then at point A and point C, 1 hour of free time costs exactly the same amount of money. In other words, the prices along the two budget lines are the same. But if prices didn't change, then the only difference between point A and point C is the purchasing power of the consumer. In other words, the only difference between the 2 points is the income that the consumer has. So by moving the consumer from point A to point C, we are answering the following question: what will the optimal choice of this consumer be if she faced only income changes and no price changes whatsoever? In other words, what part of the change in her behavior is due to the change in income only? But if we're able to answer this question, then we're able to isolate the income effect from the substitution effect. And this is exactly what we're doing here. The final step in our analysis will be to hold the welfare or utility unchanged, assume that it reflects identical income, and then change the price to the new one. This will give us an answer to the following question. How will her optimal choice change if there was no change in income, but there was change in the price only? In other words, we will be seeing what part of the change in her behavior is due to the price changes alone, not the income. So as moving from point C to point D happens on the same indifference curve, we know that the consumer is neither better off nor worse off. Then we say that her purchasing power did not change. It didn't change. Or her income, therefore, didn't change as well. But if that's the case, then the entire change of her behavior from point C to point D happened not because of her income, but because of the price change. This is what we call the substitution effect. Notice one important fact. In this case, the income and the substitution effect work in the opposite direction. And the total effect is that an increase in the wage rate forces the consumer to reduce her free time and work much more than before. In this particular case, the substitution effect dominates the income effect. In other words, your desire to work more because it gets expensive to laze around dominates your desire to enjoy life and have both extra free time and extra consumption. However, also notice that the above case is only a particular case and needs not be the case in general. For example, if the wage increase is far more dramatic than the move from $15 to $25, or if preferences are somewhat different than the ones of this consumer, we may well end up in a new equilibrium with more free time and more consumption. An equilibrium in which the overall effect was positive for both leisure and consumption. This last equilibrium change is the observed shift in the working hours and consumption along the last 100 years. In this week's live lecture, we will set this theory in motion. We'll go back to the data and see its powerful explanatory power. We'll go back to the data and we'll employ this model to see its powerful explanatory power for the dramatic changes that have occurred in both working hours and consumption over the last century. So the next video summarizes what we have learned this week. Thanks for watching.